Hello physics and AP Physics. This is going to be a video introducing something called the motion or the kinematic equations, and then a little bit on how to use them, but really just an introduction, okay? And for those of you that are in physics, you should get out the motion equations. They should be on Schoology. They're also in the Google Drive folder in the important handouts folder. For AP Physics, you'll see very similar equations as at least the first three on the equation sheet from College Board. I'll talk about those slight differences in class with you guys at some point, but you'll be able to algebraically move the stuff around and see that it's the same thing, okay? All right, so let's go ahead and introduce these, okay? Oh, there's a very important condition placed on these equations that we're going to use, and that is that we have to have constant acceleration. All right, so for these kinematic or motion equations, we have to have constant acceleration. If we don't have constant acceleration, you can't use these. And we'll talk more about that and how to do problems that have accelerations that are non-uniform later in the course for both physics and AP Physics. We have some other tools in our tool bag to use besides the motion equations. I'm typically going to call them motion equations. I'll sometimes call them kinematic equations. Kinematic, we're just talking about motion. Okay. All right, so I'm going to go ahead and put the first one up here, and that is V equals V naught plus AT. V equals V, that's the naught symbol. Okay, that stands for initial or beginning. Okay, it's not an O or a 0, but if you want to think of it as a 0, or if you want to use a VI instead of V naught, that's perfectly fine. This is just what you'll see a lot of times in textbooks and what I've gotten used to using over many, many years. Okay, now I'm going to add something here. This is what it'll look like to you guys on your equation sheet in physics, and I think in AP as well. I'm going to go ahead and add a V final. Okay, we'll talk more about what each of the variables are here in just a minute. And the second one on your equation sheet for physics, make sure I got the right one here. Yeah, the one that starts with x minus x naught equals V naught t plus 1/2 AT squared. So that's the second one. Okay, well, again, we'll get to all the variables in just a minute. The third one, V final squared. Oh, and this V final won't initially be there. It'll just be a V squared. V naught squared plus 2a times x minus x naught. I'm now going to add the f. And again, if you prefer, you could use like an I and an f, or a 1 and a 2 if that's your preferred subscript. That's okay. It's all interchangeable. Okay, and you could leave the f off of the v as well. Okay. All right. Now, those are the three that you really need. These other two you can derive from the first three. And I'm gonna look over here on the sideboard because I don't remember. This is enough for me to solve any problem you give to me. Okay, but I'm gonna go ahead and write the fourth and the fifth one. If you are in AP, I doubt you will ever use one of these because they're not on your equation sheet. What you'll end up doing is using one of the first three and then using another one from the first three. In regular physics, since you can make your own equation sheet and you can put these two on here, you might end up using them. So x minus x naught, yeah, 1/2 V naught BFT, that's right. And then the last one, x minus x naught equals, yeah, VFT, V final, times t minus the 1/2 AT squared. Okay, so there they are. There's your 5 kinematic or motion equations. And then we're going to talk about what's missing from each one of these equations. Okay, now when you're looking at these equations, treat x minus x naught as one variable. Okay, if you want to just write an x or a delta x, that's fine, but treat this as one variable. Okay, and look here, how many variables do we have? 1, 2, 3, 4. So we've got 4 variables. Okay, which one is missing? It's the x minus x naught. So from the first equation, we are missing an x minus x naught. Okay, so if you're doing a problem and you're trying to solve for that thing, you wouldn't use this. Okay. But let's say maybe you don't know what x minus x naught is. It's missing from the problem and you're not trying to solve for it. Well, then this might be a good equation to pick. So the missing column over here that I'm going to fill out will help you decide which equation to use when. Okay. All right, so we got missing here. We got V final missing from this one, or V. From this one, we're missing T. From this one, we are missing A. And from this one, we are missing V initial, or V naught. Okay, so that's missing from each one of those. Okay, now the question is, what does each one of these variables mean? I'm going to give myself a little bit more room here. Okay. Also going downhill a little bit here. There we go, okay? So what does each one of these variables mean? So I'm going to talk about each one of these, okay? Let's start with the one that you probably already know just by guessing. By the way, that's a cursive T. If I wrote a T like that, it would look a heck of a lot like a plus. So to avoid that, there's my cursive T. But if I get messy and we get something like that, that's still a T. So that's my cursive T to avoid confusions with pluses when we're doing problems, okay? T is the one you could probably guess if we're dealing with motion. One of the things we care about is time. So T is time measured in seconds. So I'm going to put the base units over here. This information is not on your equation sheet, but you are welcome to add it, okay? Or on the PDF or whatever. You can add that on there if you want, okay? Let's go to another one you might have a guess for when dealing with motion, A. A is acceleration. And our base units for that are meters per second squared. So meters per second squared. And I would encourage you to write your fractions with horizontal lines instead of slashes unless you're typing something. It will help you quite a bit when you're dealing with improper fractions and you got messy equations or messy units to deal with. This will cause less problems than if you write it like that. That's bad. Don't do that. It'll cause you problems at some point. Okay? Maybe not in this class, but at some point it will mess you up. All right. Now let's talk about the V's. You could probably guess that these have to do with how fast and which way it's moving, okay? The vector known as velocity. Where VF, I've added the F, remember, it just says V for you guys, is the final velocity. Final velocity. And V initial is the initial velocity. And this is why I said you could use 1s and 2s if you prefer, or an I and an F, because this is our starting velocity, this is our ending velocity. Now when I say it's our starting and our ending velocity, what I mean is this velocity has to come after this one. It's up to you in most of our problems to decide when does the problem start and when does the problem end, or which part of the motion are you looking at. And you pick, oh, I'm going to start at this point, call that V initial. I'm going to finish at this other point, I'll call that V final. Okay, and that will also correspond to this, okay, our x minus x naught, which is our change in position, okay, our change in position, where we where we finished minus where we started. So that is the same thing as a delta x there, the change in x, okay, the final location minus the initial location. In fact, I could put an F on that if I wanted to, okay. Whoops. All right, and now that we know that's change in position, we got another name for that. Displacement. That's how far and which way that we went. So that is our displacement. That's our displacement. Okay, so those are our 5 equations. And when you're doing one of these problems, okay, what you're going to do is you're going to decide which way is positive. You're going to draw a picture. You're going to list your 5 variables, and you're going to try to fill out 3. And great news, if there are 3 numbers that you can pick out from the problem and put the correct sign on them for 3 of these variables, you're home free. Okay, you can just pick one equation and solve. Okay, and oftentimes that will happen. If you're in AP Physics, it might be a little more involved than that. It might be that you're picking out 2 variables and there's a third one that you can get from some other equation or something like that that you can substitute in. But it's still the same idea. It's the same process of trying to be like, what are 3 things that I know in this problem of these variables? And if I can figure that out, then I can find the other 2. Okay, typically you're just going to be looking for one of them, but if you want both of them, you can then solve for both of them. And this will usually be, for regular physics, you'll have numbers for just about everything. For AP, it might be you're deriving some equation in terms of other variables, and that's still the same process though. Instead of putting the number in, you'd put a check, and you'd be like, okay, yeah, that's the thing that I want to be in my equation. I want something I know or I want to have in the equation. But the missing is still going to be the same idea. It's something you don't know or don't have any other information about that you can plug stuff in for, and you're not trying to solve for it. So it's like the don't care. It's the thing you don't care about and you don't know what it is. You want it to be missing from your equation. All right, so hopefully you have these in front of you. If not, take a screenshot right now. Hit pause, take a screenshot of the equations, and then have it next to you while you watch the rest of the video, because I'm going to erase all this now. Okay? Again, these are the motion equations or the kinematic equations. All right, So let's just set up some real quick problem here. I'm not going to write all the words. I'm just going to draw a quick picture. But step one, when you're doing any of our problems that are assigned, you have to draw a picture. If you're going to use the motion equations, you have to draw a picture. That's something that is required because I have to know what you're thinking about inside your brain. Like, are you picturing the car going right or left? Okay, we're talking about various directions and it doesn't specify. Maybe you've got it going, south or west, or it depends. So typically, right now we're doing 1D motion. So I need to know which way is it going. For left to right problems, I need to know if you're picturing going right or going left. You don't have to draw anything fancy. Everything could really be just a box with an arrow, okay? It doesn't matter if it's a car or a person or stick figures for people, but it doesn't really matter. As long as you have some object and you show me which way you're picturing it going, that's what I need at the get-go for the picture part. So let's say we have a car, all right? And the car, and I'm saying the words for the problem, okay? And the car is moving at 3 meters per second, and in my mind, okay, I have it going to the right, okay? And then we'll say that 5 seconds later, the car is now moving 2 meters per second. All right? So the problem would say something like, a car is traveling along at 3 meters per second, and 5 seconds later, it's traveling in the same direction, but now it's going 2 meters per second. And let's say we want to find the acceleration. All right? Oh, this little half arrow that I'm writing here is to emphasize that this is something that is a vector. It has magnitude and direction. Okay? I won't always write that, but that just emphasizes that, hey, it's a vector. In the book, oftentimes in books, okay, including some of the sources we use, this will be written in bold if they're emphasizing that it's a vector. I won't always write it, but when I say find A, that can be confusing if I don't emphasize that this is a quantity, the quantity acceleration. Okay, so we're trying to find the acceleration. You might say, hey, I can do that in my head because I know A equals delta V over T. You got that idea? Great. That actually is one of our motion equations rearranged. But what we're doing right now is we're focusing on the process, not the answer, because we're going to get problems where there's no way you'll be able to do them in your head. I'll fill this whole board for both physics and AP physics. I'll fill this whole board with work, okay, for like one problem, okay? And probably writing about that size, okay, so you can imagine, oh, you can't see the whole board, but it goes a couple feet that way in both directions. All right, so we're trying to find the acceleration. Now, in your actual picture for this, if you were doing this, you don't have to put all this information on your picture, but if you're stuck on a problem, that's the kind of thing you should do. Add information from the picture, think about it, see if it makes sense. So what would you actually need for your picture on this one? I would just need that. There you go. That's it. I got a box going to the right. I know how you're picturing the object moving at the beginning. That's sufficient. But you would also need which way is positive. Okay? Since this is a one-dimensional problem, I'm just going to go ahead and say right is positive. If we were doing a two-dimensional problem, I would say up and right is positive like that. Okay? At some point later in the course, if you don't write it, I will assume these things. Also, if I don't write it, you may assume these things or call me on it and ask, but typically I will, especially for the first couple times we're doing problems like this. Okay? But that's overkill for this one. I'm just going to leave it like that. So there's my picture. I'll put some wheels on there maybe. All right, and there's the which way is positive. Okay? You have to do these two things on these problems. So now what do you do next? You list your 5 variables. I don't care about the order, but if you want my help, okay, or for regular physics, if you're practicing for our assessments, you do need to put the 5 variables in a column. Okay? It's just a convenience thing so that I can quickly look at your screen or look at your work and catch the 5 variables like that. Okay? And somebody else can do the same thing. It's not that it's better than other ways, it's just what I'm used to, and we're standardizing it. So if you want help from me, okay, or you're in regular physics and you want to practice for the test, okay, 5 variables in a column. In other words, put the 5 variables in a column. Okay. All right, so I'm going to go ahead and write them, but I don't care about the order, and I just want them in one place. Oh, instead of A, I'm going to go ahead and write AX. Eventually, we will do problems where stuff is moving in the X and the Y direction, like when I'm tossing, when I'm tossing the marker. So maybe I should toss Mario Ball. Where's Mario Ball? Let's toss Mario Ball. Okay, so like when I'm tossing Mario Ball here, okay, he's moving in the X and the Y direction, that being the typical math thing, XY axis like that, X left to right, Y up and down. And when we're dealing with those problems, we'll have stuff going on in the X and Y direction. So you might want to get in the habit right now of adding subscripts to things so that you know that they are just for the X or just for the Y. Okay? this is already covered because we wrote x minus x naught. If I was doing a problem up and down, I would call this y minus y naught if it was in the vertical. All right, so acceleration in the x, initial velocity in the x, final velocity in the x, and time. Okay, so there's my 5 variables. And now I'm going to go ahead and try to fill out 3 of these. Okay, and if I can't, I'm home free. And I've set up a pretty straightforward problem here. We can fill out 3 right away. Okay, and we're looking for the acceleration of the x. Okay, and what do we know? Well, I know the car was moving, in my picture, at 3 meters per second to the right. So that'll be a positive 3 meters per second. You do have to think about the signs when you write these numbers. If I had called left positive, I would be plugging in right now a negative 3 meters per second. All right. V final x, get that from right there. At the end of the problem, the car was going 2 meters per second to the right. So that's positive 2 meters per second. And then our time. This whole process took 5 seconds. There's something else I don't know, displacement. Now, I'm trying to find acceleration. So if I'm trying to find it, it should be in my equation, right? Because if it's not my equation, I can't solve for it. So I do want acceleration to be in my equation. The thing I don't want to be in my equation is the thing that has a question mark that I don't care about. Not trying to figure out what it is, and I don't know what it is. I don't care. I'm just going to put a DC there. You don't have to put the DC. You should put the question marks, though, okay? But I don't care about the displacement, so I want it to be missing from my equation. So now you take a look at that screenshot from a little while ago, or you look at your equation sheet, or just look at the equations, and which one do you want to be, which equation do you want then? The one that doesn't have this? It's that V final equals V naught plus AT. All right, so let's go ahead and use that. V final equals V naught plus AT. And to be consistent with my variables over here, I am going to go ahead and add the subscripts on these because this is all stuff in the x, this is all stuff in the x direction, all stuff left to right, okay? All right, so let's go ahead and plug these numbers in. Oh, this is the point where the physics is over. This is the physics, okay? The rest of this is going to be Algebra 1 stuff. I'm just going to substitute and solve. Let's go ahead and do that now. 2 meters per second is my V final. My V initial is 3 meters per second. Acceleration, that's what I'm solving for. Time is my time, which was, what was it, 2 seconds? No, 5 seconds. 5 seconds. There we go. And the units, by the way, if you do the algebra to the numbers and the variables, and the algebra to the units should check your answer. We're expecting acceleration has base units of meters per second squared. We're expecting to get meters per second squared when we solve this. All right, so I'm going to subtract 3 from both sides. So 2 minus 3 will be negative 1 meter per second equals AX times 5 seconds. I just subtracted 1 from both sides. And now I'm going to divide both sides by 5 seconds. Over here, that'll cancel out. And I'll get my acceleration, the x, okay, is negative 1/5, okay, but we shouldn't really leave it as a fraction because sometimes that can get us in a lot of trouble, okay. 1/5, same thing as 2/10, so it's 0.2. So negative 0.2 meters per second squared. Now, what does that mean, okay? What does that mean when we have that negative 0.2? At some point, this will be, I'm sure, said in class, okay, as well. When your acceleration is in the opposite direction of your velocity, you're going to slow down in terms of the arrows. When your acceleration points in the same direction as your velocity, you're going to speed up. So let's think about which way our velocity was pointing at the beginning. It was pointing to the right. We just got an acceleration that is negative, and that is a vector, just to remind you. That is a vector. So a negative means that that vector, that acceleration, points to the left. When they're opposing like that, okay, that means you're going to have to slow down because what's acceleration telling you about? It's telling you about how your velocity is going to change. So if we're changing that way, we are going to slow down. Now, if we kept going to like 6 seconds, 7 seconds, 8 seconds, 9 seconds, at some point, if the acceleration stayed the same, we would come to a stop and then start to go the other way. And then when we started to go the other way, the acceleration, the velocity would point the same way, and we would speed up. Okay? And that is true in the x direction, the y direction, and an angle, doesn't matter. If your acceleration velocity vectors point the same way, the object is going to speed up in that direction, okay? If the velocity and acceleration point in opposite directions, your object's going to slow down, stop, and eventually start to go the other way, and then it'll speed up, okay? All right, one more thing here, and that is, what if I had called left positive, okay? Oh, and keep in mind when we did this problem, we just got that the acceleration for our answer pointed to the left. We just got an answer of acceleration to the left. Let's see what would happen if we called left positive. Negative, negative, right? Negative, negative, negative 2, okay? Minus a minus 3. Let me make that a little bit clearer now. Negative 2. All right, so we are going to go ahead. Sorry, I misspoke there. We're going to add 3 to both sides, okay? So we're going to add 3 to both sides. So now we're going to get 1, and we would get a positive 0.2 meters per second squared. You might say, oh, wait a minute. Mr. Ward, all you did was change which way is positive, and we got a different answer. Well, we got a different numerical answer here, but it means the same thing. So remember that our acceleration should be pointing to the left. Well, this time I called left positive. Sure enough, we get a positive answer. That means our acceleration points to the left. So the car is moving to the right. Acceleration points to the left. The direction is to the left, positive in this case. And that's why the car is slowing down. So remember that when we're talking about vectors, okay, it's about which way they're pointing, not necessarily just their signs. If you know the sign on the vector, the positive or negative, and then you know which way is positive, then start pointing and thinking. Don't just base it on the negative or the positive by itself. Negative acceleration could mean speeding up. It could also mean slowing down. And special for one-dimensional motion. Special cases later on something else. But all right. I think that's it.